नमस्कार विद्यार्थी मित्रांनो. सध्या लॉकडाऊन पिरियड चालू आहे, त्यामुळे आपण कॉलेजमध्ये तुम्हाला शिकवू शकत नाही. यासाठी आपण यूट्यूबच्या माध्यमाचा वापर करणार आहोत.
Today we are going to start transition and inner transition elements. Transition elements are D block element, while inner transition elements are F block elements. First we are going to see transition elements or D block elements, in which we are going to see introduction, position in periodic table, electronic configuration of 3D series, oxidation state of 3D series, and physical properties of 3D series elements. Transition elements. Introduction. Transition elements belongs to D block elements in the periodic table. These elements are placed in between S and P block elements of the periodic table. These elements have incompletely filled D orbit. These elements exhibit properties between S and P block element. Now we know that S block elements are alkali metals and alkaline earth metals. In case of P block elements, there are metals, metalloids and non-metals. D block elements gives rise to electropositive ions, that is cations, with incompletely filled D orbit. There are 4 transition series elements: 3D, 4D, 5D and 6D. 3D series constitutes 10 elements from scandium to zinc. 4D series constitute 10 elements from yttrium to cadmium. 5D series constitute lanthanum to mercury, and 6D series constitute 10 elements actinium to curium. 5D series starts with lanthanum, in which valence or last electron enters in 4f orbit. Therefore, 14 elements following lanthanum are called as lanthanoids, in which valence electron enters in 4f orbital. This is first inner transition series. 6D series starts with actinium, in which valence or last electron enters in 5f subshell. Therefore, 14 elements following actinium are called as actinoids, in which last or valence electron enters in 5f subshell. Therefore, this is second inner transition series. Position in periodic table. Transition elements are placed in the periodic table from period 4 to 7 and in the groups 3 to 12, which constitutes 3D, 4D, 5D and 6D series. These elements are placed at the center of periodic table in between S and P block elements. 3D series constitute elements from scandium to zinc, which are present in 4th period. 4D series constitute elements from yttrium to cadmium, which are present in 5th period. 5D series constitute elements from lanthanum to mercury, which are present in 6th period, and 6D series constitute elements from actinium to curium, which are present in 7th period. Electronic configuration of 3D series elements. 3D series begins with scandium having atomic number 21 and ends with zinc having atomic number 30. Third period ends with argon having atomic number 18, which is a noble gas which precedes the 3D series. The electronic configuration of argon is 1s2, 2s2, 2p6, 3s2, 3p6. After argon, fourth period starts. The second element of fourth period is calcium having atomic number 20, which belongs to S block. The electronic configuration of calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, that is argon 4s2. After calcium, 3D series starts. The first element of 3D series is scandium having atomic number 21. The last or valence electron enters in the 3D orbital in case of scandium. The electronic configuration of scandium is written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d1 and 4s2, or it can also be represented as argon 3d1, 4s2. Electronic configuration of 3D series. Now there are 10 elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. The electronic configuration of scandium, titanium, vanadium shows similarities in expected electronic configuration and observed electronic configuration. But in case of chromium, there is difference in the expected electronic configuration and observed electronic configuration. Expected electronic configuration of chromium is argon 3d4, 4s2, and observed electronic configuration of chromium is argon 3d5, 4s1. This is due to stability rule. According to stability rule, completely filled d orbital is more stable than half filled d orbital, which is more stable than empty d orbital, and which is more stable than partially filled d orbital. Therefore, chromium shows difference in expected and observed electronic configuration. The expected electronic configuration of chromium have half-filled 3d orbital, which is more stable. In case of manganese, iron, cobalt and nickel, there is similarity in expected and observed electronic configuration. But in case of copper, like chromium, according to stability rule, there is difference in expected and observed electronic configuration. The electronic configuration of copper is argon 3d9, 4s2, and observed electronic configuration is argon 3d10, 4s1. In case of observed electronic configuration of copper, 3d10, that is d orbit is completely filled, which is more stable. Therefore, there is difference in the expected and observed electronic configuration of copper. Lastly, zinc shows the similarity in the electronic configuration in the expected electronic configuration and opposite electronic configuration. The elements in which 3D orbit is completely filled, that is 3D type, are not regarded as transition elements. For example, zinc, having atomic number 30, has completely filled 3D orbital, that is having electronic configuration 3D10 4s2, and therefore here there is 3D orbit is completely filled, that is 3D10, and its +2 oxidation state also it has completely filled 3D orbital, that is 3D10, therefore it is not regarded as transition element. On the same condition, cadmium and mercury from 4D and 5D series are not considered as transition elements. In case of copper, the electronic configuration is 3D10 4s1. Here also there are 10 electrons in 3D orbit, which is completely filled. But in its +2 oxidation state, copper has 3D9 electrons. Therefore, copper is a transition element. The general electronic configuration of 3D series is argon 3D 1 to 10, 4s 1 to 2. 4D series krypton 4D 1 to 10, 5s 0 to 2. 5D series xenon 5D 1 to 10, 6s 1 to 2. 6D series radon 6D 1 to 10, 7s 1 to 2. The electronic configuration of chromium and copper. The general electronic configuration of 3D series element is 3D 1 to 10 4s2. But chromium and copper shows the difference in the expected electronic configuration and observed electronic configuration. The energies of 3D and 4s orbitals are nearly similar. Therefore, electron can pass from 3D orbit to 4s orbit and 4s orbit to 3D orbit. According to extra stability rule, completely filled d orbit is more stable than half filled d orbital, which is more stable than empty d orbital, which is more stable than partially filled d orbital. The expected electronic configuration of chromium is 3D 4 4s2, but observed electronic configuration of chromium is 3D 5 4s1. In observed electronic configuration of chromium, 3D orbit is half filled, which is most stable. In case of copper, having atomic number 29, the expected electronic configuration is 3D9 4s2. But observed electronic configuration of copper is 3D10 4s1. In observed electronic configuration of copper, 3D orbit is completely filled, which is most stable according to stability rule. And therefore, there is difference in the expected and observed electronic configuration of chromium and copper. Oxidation states of first transition series, that is 3D series. Oxidation states means having positive or negative charge on the atom, that is formation of ions. If the electrons are given out, then positively charged ions or positive oxidation state is acquired. And if the electrons taken by the atom, then negative oxidation state is obtained to atom. 3D elements or first transition series elements shows variable oxidation state in their compound form. Due to loss of 4s and 3d electrons, there is formation of ions takes place. Generally, these 3d elements are electropositive elements, therefore they loses electron and acquires positive oxidation state. When one 4s electron is loosed, then formation of M+1 ion takes place. By the loss of two 4s electrons, M2 plus ions are formed. When unpaired electron present in 3d orbital and 4s electrons gives M3 plus and M4 plus ions, and so on. Scandium has only one unpaired electron, having electronic configuration argon 3d1 4s2. Therefore, it can show two oxidation state, that is +2 and +3. While in case of manganese, there are 5 unpaired electron in d orbital. That is, the electronic configuration is argon 5d, argon 3d 5 4s2. Therefore, our manganese shows 6 different oxidation states. For example, manganese shows +2 to +7 oxidation state. Oxidation states of 3D series. First we are going to see scandium. Outer electronic configuration of scandium is 3d1 4s2. By the loss of 2 4s electrons, +2 oxidation state is obtained, and by the loss of 3 electrons, that is 3d1 and 4s2, +3 oxidation state is obtained. Here +3 oxidation state of scandium is more stable because it acquires argon gas configuration, which is more stable. Titanium. Outer electronic configuration is 3d2 4s2. By the loss of 2 4s electron, +2 oxidation state is obtained. By the loss of 1 3d and 2 4s electron, +3 oxidation state is acquired. And by the loss of 3d 2 electrons and 4s2 electrons, +4 oxidation state is obtained. +4 oxidation state of titanium is more stable due to argon gas configuration. Vanadium having electron configuration 3d3 4s2, which have +2 +3 +4 and +5 oxidation state, in which vanadium +5 is more stable since it acquires argon gas configuration. Chromium 3d5 4s1. Chromium shows +1 +2 +3 +4 +5 +6 oxidation state. In case of chromium, +6 oxidation state is more stable. By the loss of 6 electron, chromium acquires argon gas configuration, which is more stable. Manganese. Electronic configuration is argon 3d5 4s2. It shows +2 +3 +4 +5 +6 +7 oxidation state. +6 and +7 oxidation state of manganese are most stable. The in +7 oxidation state, manganese shows stable argon gas configuration ion, having outermost electronic configuration 3d6 4s2. It shows +2, +3, +4, +5 and +6 oxidation state. The +2 and +3 oxidation state of iron are most stable. In +3 oxidation state, iron shows stable argon gas configuration, cobalt. (3d7 4s2). It shows +2, +3, +4, +5 oxidation state. In +4 oxidation state, cobalt is most stable. In +4 oxidation state, cobalt have half-filled 3d orbital, therefore it is most stable. Nickel 3d8 4s2. It shows +2, +3, +4 oxidation state. Copper 3d10 4s1. Shows +1 and +2 oxidation state. 3d10 4s2, which shows +2 as a stable oxidation state. Physical properties of first transition series. All transition elements are metals and shows properties of metals. They are hard, lustrous, malleable, ductile and form alloys with other metals. They are good conductor of heat and electricity. Except zinc, cadmium and mercury, all the other transition elements have one or more typical metallic structure. These transition metals, except zinc, cadmium and mercury, are very hard and have low volatility. They possess high melting point and boiling point. Here we have completed today's lecture. Homework for you. Question number 1, give position of transition elements in the periodic table. Question number 2, give position of iron in the periodic table. Question number 3, iron exhibit +2 and +3 oxidation state. Write their electronic configuration which will